Just comment below. I will check through the comments. So the simple correlation and the complex correlation now. Like, what is simple correlation? Like, from the word simple, this simply means that we are actually looking for a degree of relationship that exists between just two variables only. Now, for complex, it shows that, like opposite of simple, complex. So it shows that we are looking at the degree of relationship that exists between three or more variables. Okay, so now let's talk about the linear and non-linear aspects of correlation. Linear and non-linear of correlation. Like this one asks you, like, you know, the linear aspect and non-linear aspect. Okay, I'll put it this way. A correlation is said to be linear. A correlation is said to be linear if a change in one variable brings about a constant change in another variable. I'll come again. A variable is said to be linear if a change in one variable brings about a constant change in another variable. But for non-linear now, if you ask you what is the non-linear aspect of the correlation, okay, you can say a correlation is said to be non-linear if a change in one variable brings about a different change in another variable. You are correct. Okay, let's talk about the positive aspect of this. The positive aspect and negative. Positive and negative aspects. Okay, basically we're talking about that, okay, like the positive aspect and negative aspect of the thing. We can look at it in this direction. We can say that the two variables that are related in this case, if the two variables moves in the same direction, then there is a positive relationship between them. I will come again. Like if the two related variables in a correlation analysis moves in the same direction, then you can say there is a positive relationship. But if the two related variables moves in opposite direction, then you can say it is a negative there's a negative relationship between them. Like, I want you to take note of this key point here. If you see the word, like this stuff here, like saying same direction, opposite direction. This means negative. This means positive. So in case you probably come across something like the same direction, it simply means the two variables are moving in the same direction. So we can call it positive. But for this one, now we have opposite direction. We can just say, okay, since the two related variables are moving in opposite direction, then we can term it or call it negative. So that is negative relationship exists between the two variables. But for this, positive relationship exists between the two variables. So let's talk on the methods. Methods of solving correlation analysis. There are basically three methods of solving correlation analysis. The first one here, we have the scatter diagram. The second one, we have the simple correlation coefficients. The third one, we have rank correlation coefficients. So I will take a look at the following one after the other. I'm going to start with this first. Then go into this with the likes. So, what is pattern diagram? There are things I want you to take note of, like the function of scatter diagram. Looking at it, this actually shows a visual relationship between two variables. That is basically what scatter diagram does. And also it shows the strengths that exist between two variables. Look at what strength is. The strength is telling you that okay, it can be either positive or negative, in case you don't know. The strength simply talks about this, the positive aspect and the negative aspect of it. Okay, so let's take a look at, let's solve one question to justify what I've just said. Still on the diagram. Okay, let's take a look at it. Given x value and y value. Let's say x is 1, 2, 3, and y is let's say we have 10, 20, 30, and we have to represent the above data using the scatter diagram. If I'm to solve this, how will I go about it? It's just a normal solving. You can recall your demand and supply curve. You can see the way it is being represented, or can we just say a Cartesian place? In the sense that, okay, let's say we actually have our x value here, and our y value will be on the vertical side. Okay, looking at it, our x here is 1, 2, 3, and our y here is what? 10, 20, 30. Now if you look at it, when x equals 1, the value of y here is what? 10. When x equals to 2, the value of y here is what? 20. Okay, when x equals to 3, the value of y here is what? 30. Now, looking at it, actually you won't, like, in case if you want to know if it is the perfect relationship, like if there's a correlation between the x and y value. Look at this is the origin here. Looking at it, I don't think I actually have. So I'm having a perfect relationship here. Like looking at it, it's more like the supply. Let's put it this way. You can remember a supply curve, something like this. And for our demand curve, something like this. I don't know, for economic students, you can bear between that, or you can do between that. Supply curve shows a positive relationship, while a demand curve shows a negative relationship. But if I'm to answer this, like if I'm to like interpret my results based on what I'm having here, I'm having a perfect positive relationship. You can say there is a perfect positive relationship between the two variables. I want to take note that your interpretation or your conclusion really matters a lot. I think I'll come again. I don't think you really probably understand how I come across positive or negative. Like just like your demand and supply. Or you know that our demand is a negative. I mean, it's always negative. Why our supply is always what? Positive. Now, if you compare what you have here with this, you could see that the supply curve is what is upward sloping, while demand is going downward sloping. So I feel looking at it this way, you can get like and reduce your opinion, your comments on it. So you can solve it. You can solve any scalar diagram, like any questions on scalar diagram. You can solve them using this form as well. Okay, that's that. So let's move to the second techniques used in solving correlation is known as the simple correlation coefficient.